Good morning everyone. This lecture deals about doubly reinforcement beam and its design philosophy. Myself Dr. J. Sahayaravan, Professor and Head, Department of Civil Engineering, Rohini College of Engineering and Technology. First of all, what is doubly reinforced beam? The doubly reinforced beam, the reinforcement is provided tension as well as the compression side. The steel reinforcement in both tension and compression zone are called doubly reinforced beam. If we consider in the normal general case, the bottom portion have tension and the top portion we are providing, which is nothing. But in the compression zone, we are providing steel in the tension zone as well as the compression zone. Where do we need it? Where do we need this reinforcement? We need that reinforcement because your depth is not adequate. You could not provide the depth required if you have to design it as a singly reinforced section. In that case, because it is restricted, maybe due to the architectural point of view or maybe some other reason. So, we have to provide, then what we can do, we provide the compression zone. We provide the steel in the compression zone and we do the design, and that is called doubly reinforced beam. It may be happen that say due to the moving load, particularly in support where you have that the compression as well as the tension. There is change of sign in the bending moment. There also you have to provide the reinforcement in the tension zone as well as the compression zone. So, what is the design philosophy of doubly reinforced section? The design philosophy of doubly reinforced section, we shall provide the tension reinforcement in both the direction. That is tension reinforcement as well as the compression reinforcement. Let us say the tension reinforcement is AST and compression reinforcement is ASC. We can make into two parts. We can say that we are having the portion, the beam having a singly reinforced section. That means the moment of resistance if we consider as the singly reinforced section. The tension side only that reinforcement will be provided. Therefore, I can say this portion of steel, let us say AST1. The steel AST1 duly singly reinforced section plus remaining portion, I can provide it assuming that only the steel action, that is the ASC, the area of compression zone, and that AST2, the area of tension in the tension zone. So, you have to steel in the section side, we have two parts. AST1 will not be equal to AST2. As we are assuming that considering it is a balanced section, due to the balanced section, whatever steel we require, that is AST1 plus AST2. So, individually this portion also will be in equilibrium, as well this one also will be in equilibrium. ASC and AST2 should not be equal. It cannot be equal because the top strain in the top portion and the strain in the bottom portion will be a differ. So, that is why that area of the force, whatever we shall get it from the force, is equal, because that one supposed to be in equilibrium, but not necessarily ASC and AST will not equal, because the stresses are different in two different zones. We could further explain, we have, if we draw the stress strain diagram, the strain, the diagram, if we consider Fe415, assuming Fe415 at the top, so 0.0035 in the compression zone strain. We are having 0.0038 in the tension zone considering Fe 450. So we provide the steel at the zone in the compression and the tension, the strain value are differ. As I already discussed, the strain are differ in the compression zone as well as the tension zone. The epsilon SC is equal to 0.0035 for compression and 0.0038 for tension zone. In case of you are using Fe 415, this is a value in compression as well as the tension zone. But in other side, if you are using a different reinforcement, we have get the different strain value. This is a stress block we have to use for calculation of design of doubly reinforced section. Let us see this stress strain curve for concrete. We are using this curve, it depends upon the strain value. Up to 0.002 we shall come back up to 0.002 strain. Beyond that we get constant stress in concrete, which is comes as 0.45 FCK. This portion less than 0.002 strain, we shall get the parabolic when we get the corresponding stresses, because we have to find out the stresses. The other important part, that is a major part of our case, is because since that strain is 0.0038 for Fe 415, we are getting the value of 0.87 Fy. The 0.87 Fy, why? Because we are using the partial safety factor for the material, that is divided by 1.15 for steel. So the value is getting 1 by 1 divided by 1.15, which is nothing, 0.87 Fy. We should always remember 0.87 Fy, and the corresponding strain we shall get it from the curve. For the strain is computed, we shall get our corresponding stresses, and that we shall use it to the calculate for our forces. This is all about the doubly reinforced section design philosophy. Thank you so much.